This session is actually one of the favorite ones that we put together for this year because once you see the Microsoft 88 Acres case study, I mean, this is the kind of stuff that we've been talking about, and I think these types of case studies are phenomenal to really help people, kind of push people to take that next step to see what really can be done. So I'm going to turn it over to Carlos, who's going to lead the discussion today, and I hope you enjoy it.
Thank you. Thank you, Darlene, and welcome everyone to this session. We have some very esteemed speakers, industry leaders, thought leaders, people that have transformed the market and their space and how they are using technology to really move the needle in energy efficiency. So we'll start here with Randy Gaines. Randy currently serves as the Vice President of Engineering, Housekeeping, and Laundry Operations for the Americas, bringing 20-plus years of experience to the operations team. In this capacity, he is responsible for operations in his area of expertise. He also supports all of corporate sustainability energy conservation efforts with his organization. Next, we have Daryl Smith, Director of Facilities and Engineering at Microsoft. Daryl is the Director of Facilities and Energy for Microsoft's Real Estate and Facilities Group. Daryl oversees the facilities, management, and energy strategy for Microsoft's 15 million square feet headquarters campus in Redmond, Washington. In addition, Daryl is also RE&F's Global Center of Excellence for Energy and Sustainability. In this role, Daryl is accountable for setting the strategic direction for sustainability across Microsoft's overall portfolio consisting of 34 million square feet and over 700 sites. One of Daryl's focus areas has been anchored in innovation, leveraging IT and tools to solve big data problems and driving energy efficiency at city scale. Daryl has 15 years of industry experience in facilities, data center operations, energy management, and manufacturing. So glad to have you here, Daryl. And rounding up our group is Russ Gaines, currently serves as a vice president, Russ Argusa, president and CEO, is the founder and president and CEO of Iconics, a world-leading software developer of open connectivity and standards-based visualization software. Russ has a BS in electrical engineering from the State University of New York at Buffalo and an MS in computer science from Boston University. So we have a very, very bright set of panelists here to show you and discuss some of the projects they're working on. So we'll go ahead and start with Randy. I believe there's yours right there.
Let's find out where we are. Let's see. Sure. You had it up?
Yeah.
Oh, here you go. Is it down here?
Everything is good.
All right. All right. Launch it. Okay. Thank you. Thank you, Carlos. I am Randy Gaines. My current role is Vice President, Engineering, Housekeeping for Hilton Worldwide. I wanted to give you a little bit of history about myself before I kind of go into this deck. I started out in the Navy, so I earned enough money to go to college, and I went to college and I started working for Marriott early in my career, and then I ended up working as a regional, working as a corporate person. Went to go work for a very large owner for many, many years as Vice President, Engineering Technical Services. And our CEO left, and he landed at Hilton Worldwide, and I came over to join him, and I report to our president. So when I talk about this presentation, I like to think that I represent the boiler room all the way to the boardroom inside of Hilton Worldwide. So some of the things I'm going to talk about can kind of resonate from that level to the other level. I have hundreds, thousands of people working for me. As part of my role, I oversee all the engineering operations, all the energy. So basically, I'm the guy that oversees over $1 billion worth of P&L, and we don't make any money. So it's an interesting place to be. Let me tell you about who we are. So Hilton Worldwide. We're 4,000 hotels, 680,000 rooms across 91 countries with 10 different brands. We're on a very fast growth rate. We are an owner and we're an operator, which is unique. A lot of other hotel companies are what I would call asset light. We're possibly going to move to that model. Our company just became public recently, a few months back, so we're coming into our first quarter. So we are a growth company. We are the largest hospitality company out there. So what does it take to make things happen? And we're going to talk about technology. We're going to talk about getting these projects done. And I always like to talk about our CEO, because if our CEO gets it, it resonates. It starts from the top and works its way down. And then that trickle effect, you know, has inherently played itself out. And Chris Nassetta, local Washingtonian, like myself, I was born in Washington, D.C., really does care about what we do, and we've got his buy-in 100% of the way. So I'm going to talk to you a little bit about what we call travel with purpose. It's kind of a four-tier approach for our corporate responsibility component. All of the stuff that I'm reviewing today, if you want to take a deeper dive into it, you can check it out on our website at www.hiltonworldwide.com, and it kind of goes into some of those deeper dive pieces, but it's pretty exciting stuff. So sustainability, it's good business. It's smart. You know, some of the things that we've done at our hotels is pretty simple. Yielded returns and paybacks. We've got relamping projects taking place that, as you can see in here, have a 40 to 50% yielded return. VFDs, sensors, lighting projects. We have our hands immersed in to a little bit of everything. And we manage that through the corporate office. Now, and I've given you kind of a little bit of a dabble as to what some of these things are. And I also oversee other pieces of the business. On here, there's a water park that we're trying to implement. So it's all about that real estate transaction. Obviously, we look at those numbers, and, you know, so imagine, it's good business. It has a 40% yielded return. Everybody would want to invest in it. Now, we have had some issues. We are a management company, so we've had to get buy-in from some of our owners. And then how do we do that? We do that through consistency and implementation of certain programs. And I'll talk about some of the programs in a second. So what have we done? Just a few things we've done. The building on the left is our Hilton New York. It's about a 1,600,000 square foot piece of real estate that was built in 1964. Many of you may have stayed in that hotel. You know, we put in a 1.7 megawatt cogen plant in that hotel. We put a 200 kW fuel cell in that hotel. And then we ultimately put a green roof in to kind of just tie it all together. And this building currently, we're in partnership with Accenture's Smart Building Analytics, and we have many different providers and partners, Allerton, Schneider, and other companies. But this particular asset, you know, I can tell you its footprint. We've reduced the consumption in that building by at least 35 or 40% just by understanding the algorithm. Across the globe, we've got a lot of solar projects happening. We've got composting happening. And this was a pretty interesting project in the Hilton Fort Lauderdale. And I just kind of give you kind of what it takes. So this project for these wind turbines, they didn't yield too much as far as a financial return goes. And I'll never forget, I was in Fort Lauderdale. I had to go to a zoning hearing so we could get a variance. And for those of you who've been on the beach in Fort Lauderdale, to go above the roof line. And it took an act of Congress. They thought we were going to kill birds. They thought we were going to, you know, it's just going to be this unsightly piece. So long story short is that this project turned out to be, you know, we just fired it up. It was in the Miami Herald, it was Green Biz, it went viral. So not only are these projects yielding a bit of a return, so this was, you know, we put a few $1 million in here, and it was kind of a push on the payback, but also that whole piece that we learned from this one was, wow, we're getting press, people are coming. We're in the hospitality business. If we can talk about our footprint and talk about, hey, what we're doing and how we do it, it was tremendous, and so that's been a lot of fun. And This is just a small example of several different projects that we've got going on around the globe. So what has it yielded? So everyone always, I'm a numbers guy. That's what I have to do. That's what I do because I'm not making the company any money. So we're constantly measured. So we started in 2009. We implemented a program called LightStay. And basically, we used Energy Star. We used CBEX data. We had all kinds of tracking and measuring. We said, look, we're going to come up with a plan. It's going to be a 5-year plan to reduce our energy, water, and waste. We're going to put a goal against it. We're going to make it a brand standard to use our system. So we built it, a system called LightStay. Currently, that system, I think, is one of the most robust databases in the globe. We have over 4,000 hotels worth of data. It's ISO 14001 certified and ISO 9001 certified. And for those of you who understand ISO, and this is like the first audience that I've talked to in a long time that really gets what ISO is. For us, that's exciting. And for those of you who know what's happening with 50, the triple play is not far off. And so we are very proud of the fact that that system we put in, it's basically energy, water, and waste. It measures. It tells us where we need to go. We look at high cost, high use. We beat it down. The bottom line is after we've done all of that, through the year of, from 2009 through the end of the year of 2012, it has yielded us as a company $253 million of measurable savings. And normalized for weather, so I can get all that out of the way, same store, year over year, and it's been great data. So our CO, we've reduced our CO by 12.8% since we've implemented it. We've reduced our waste by 24.9%. That exceeded the goal, and that's pretty easy. And I'll talk a little bit about some of the things we're doing around that. And then we've reduced our energy usage by 12%. That number is going to shoot up for this year, and we've met our goal for water of 10%. So, you know, a couple things that we've done, and I'm going to just talk to this slide. We've partnered with shipping and receiving, and we've looked at it, and we have 1,700 SKUs that we now are analyzing and representing some high-spend stuff, so that's yielding the waste. We work with a company called Global Soap, where we recycle all the soap, because guess what? All the housekeepers roll up to me, so it's, hey, we're going to recycle soap, so we can roll it out. We're very flat in that way, where we can, and so that's been a very exciting program. We're moving to shampoo bottles, and you got to keep in mind, remember, this is 4,000 hotels, so it's crawl, walk, and run, and it took us a long time to stand up. And we've definitely reduced, 540 million square feet of space is tracked in LightStay. So that is just a tremendous number, and we're very proud of those results. So all in all, that's what we do. I can go into a little more detail around LightStay and around what we do. We're in the cogen business. We're the 5th largest restaurateur in America by default because we own a hotel company. So we're in it, and we've dealt with a lot of the great companies that are here, and we appreciate their partnership through UTC and Schneider and everyone that's here, and looking forward to answering everyone's questions.
Thank you, Randy. This is a very modest individual. He made a couple mentions about not making any money for his company. I'm a numbers guy too. And in the commercial real estate business, we have, in our area of expertise, we increase asset value. He does that. He retains tenants and customers without a doubt. They've increased their branding. People go to Hilton because of the things that they do. So I have to, disagree with you. You guys add a lot of value to your company and your organization and your clients. And another thing, he talked about going from, being involved in the boiler room to the boardroom. I think today's thought leader and professional really needs to have that wide range of experience to be able to sell what he's doing, what others are doing. So I was really happy to hear that and excited. So next we'll go to Daryl here and have Daryl talk about what exciting things Microsoft is doing.
It's the bottom
Okay.
line.
Okay, right there.
Lovely. So thank you for that, Carlos. And Randy, it's exciting to see what you're doing in your portfolio. It's just amazing. So I'm thrilled to be here. Core's advisor in Darlene's group here is just what fits in the sweet spot for what we're doing. So I'm going to distill 4 or 5 years worth of work and research to just a few minutes, give you some views of what we're talking about when we talk about analytics, what we're doing on our campus, and really tell you how we're changing the way we manage our buildings. And so first off, I just want to say that now everyone in this room could honestly say that they've seen Seattle on a sunny day. So I want to make sure that I made that point there. So our Redmond campus, or Puget Sound campus, also called the Redmond Campus, is a small city. It's the largest contiguous corporate campus in the world. So it's 145 structures, 125 buildings, 58,000 people come to work every day. So the town of Redmond, actually, the town doubles. We have multiple disparate systems, and that's a consequence of Microsoft's very quick growth, where when in the 90s and 2000s, there were periods where we had 3 people in every office. So there's pressure on real estate to deliver space as quick as you could. And so when we had people building buildings, developers, it just was whoever can get to the OEMs manufacturers the first, and who could meet the schedule first won. And it just happened. And it's, if you name an OEM manufacturer, type of system, type of design, we'll say yes, we have it all. We're 100 megawatt peak, so we're actually 3% of the utilities load. The load serves close to 1 million people, so we have a pretty substantial load at our campus. It's mostly hydropower, so very cheap, 5.5 cents a kilowatt hour, but we have a lot of it. And we have a 60 million annual utility spend, and the most important thing here is we're connected to 2 million points. And this is the points from our building management systems, lighting control, so all the stuff you heard today on the panel of all the data and analytics and what can you really do with that to really drive change and drive behavior. Over a 24-hour period, we collect 500 million data transactions every 24 hours and have done absolutely nothing with that data up until recently. So the problem is I have a lot of disparity. I have everybody you can think of. The problem, I have a lot of data, I don't know what to do with it. So that's kind of the 2 paths as we started going down. Now this isn't a Microsoft problem, this is an industry problem. The industry's been building buildings the same way for the last 30, 50 years. Everybody builds in silos. For me, I don't know if I make a change to the mechanical systems across the campus, did I just improve energy efficiency? Did I degrade it? Because our mechanical systems are completely separate than our energy systems, which is completely separate than our lighting control. So even doing certain operational functions, we really are unaware of the impact we're having. And that's a challenge. So our vision was really to take all this disparity onto a common platform. 2 ways to get there. Rip and replace, which was $60, $70 million. And we sit in finance. We don't do anything that's fun or cute. It had to be anchored in ROI, and there wasn't any. So plus, it was very intrusive. We would have building shutdowns, lab shutdowns, and it just wasn't a way to go. The other option is to use IT to extract the data from all these different systems, all this different manufacturing over a period of, I mean, some of our buildings are 40 or 50 years old. I know that's just breaking in here a bit, but for Seattle, that's older. And taking all this data and being able to leverage it in ways. So, be careful what you ask for, you might get it. So you get all the data, but what are you really going to do with it? So we really started with going around to our tech peers, universities, national labs with this concept of driving energy efficiency at city scale. And so in having talks with these different industries and institutions, the theme that came back was, sounds like a great concept, let us know when you figure it out. So there wasn't a beacon we can point to say, hey, they've got to figure it out, we'll follow them. So we really built our requirements, which was everything we wanted to do when we grew up. What new reporting did we want? What reporting we stopped doing because we just got too big and we just couldn't do it anymore. and what capabilities do we want? And then we went around the world looking at different vendors that provided the solutions. We started with 56 companies around the world, got down to a 6 for an RFP, and then we did a multi-vendor pilot for a year. So our pilot was the same area as the Empire State Building. So it was a 2.6 million square feet. And we looked at different things of capabilities of software as a service. You hear a lot about cloud and cloud technology. We looked at on-premise. We really wanted to test to see what the capabilities were. And then we came to a solution and awarded, the company we awarded to is Iconics. And Russ is lucky enough to be here. He's the CEO of Iconics. He'll talk in a minute. But it's really, the key takeaway here is when we first started this journey, I thought we could get to the moment that, yeah, the industry's not there yet. We're going to have to wait a couple of years. And that's not the case. There are capabilities, there are software out there. You have to decide what you're trying to solve for versus trying to just jump in. So I think that's a really key thing, is to have a strategy. And Darlene talked a little bit about this today, is making know what you're trying to solve for, right? Is it the dashboard you want? Is it analytics? Is it really employee engagement? Is it building optimization? Decide, or is it all the above? And once you have that, you can get a little bit better position. So because fault detection is where the money is, I'm going to spend a little bit of time on that. But we had 3 approaches in our pilot: fault detection, energy management, alarm management. And fault detection really is where you're able to cast a net across. We have about 35,000 assets we maintain. And we cast a net across all these assets to tell me when they're not working as designed and when somebody's made a set point change. If any of those 2 conditions happen, flag it. And so that's great. The scary thing is now I know everything that's broke on the campus. So how do you prioritize it? I'll show you what that looks like. Energy management is really about analytics. So I wouldn't say that Microsoft was managing our campus by the utility bill, but we were really close. So having just the energy data to know how you're managing, how you're knowing to react to that, automate that, put KPIs in place. And the last thing is alarm management. And we're moving from a reactive group to a proactive. So I'll say that we used to, and I've been doing this for about 17 years, and I just can't figure out why. That's really the 2 modes in real estate is either our hair's on fire or everything's fine. There's really no in between. So being able to determine when equipment starts to degrade and determine, what point do you react at versus waiting for the alarms to come in and then everybody get in a truck and run, that's a horrible way to proceed. So we think a lot about the employee experience, our costs, and if you start to be able to see when that occurs, that's impactful. That really allows us to determine how we manage it. And I would say that 80% of our time from an engineering standpoint, we were analysts. We were going through reams of data, but typically it was a manual process. Actually, I had a clipboard budget. I'm embarrassed to say I worked at Microsoft and we had a clipboard budget because a lot of our reporting was done by hand. We walked around to the chiller plants and we're Microsoft. Why are we using clipboard? So that was the other thing that we wanted to solve for, is this big data problem, reduce costs, and get rid of the damn clipboards. So this is a very small 300 CFM terminal unit. It's sitting above our head right now, providing the cooling likely. And how this works, quite frankly, is it takes the cool air from the air handler. You have an actuator that controls the damper position, fan, resistive heater, and then a thermostat. So if you're hot, the actuator opens and lets the cold air in, and the heater stays off. But if you're cold, it shuts the thermostat, or shuts the actuator, pulls interstitial air in, turns on the heater, and that's basically the way it works. Well, the fundamental thing is, I know what I told the actuator to do. I don't know what it's really doing. So what we're doing that's really, really cool is we're using all the data points as this equipment came from the factory. So we've added no meters, no sensors, no hardware. This is a completely software play. And I can tell you not only how broke something is, but I can tell you how much it's costing us in energy, wasted energy, at least an annual energy cost. So that's really the impact for us is having those optics. And you take this, and this could be any piece of equipment. It doesn't have to be a little terminal. You take the same example to air handlers, to pumps, to water systems. You have the data there. It's just being able to apply analytics across it, and that's been real profound for us. So A little bit before, because I want you to feel my pain a little bit. This is one of our 7 building management systems. If you see, I'm just showing screenshots here. If you see the colors of all the buildings across the entire campus, they mean absolutely nothing. I can't tell how's the campus performing, how much energy we're using, because we're so siloed in all our different systems. The people operating the building don't know cause and effect. Is it driving energy? If we have a windstorm or power anomaly across the campus, we roll trucks. Give me about 5 hours, I'll tell you the condition of the campus. Well, 5 hours on our campus, that's a really long time. We have a lot of products we're doing, we're development, we have hardware labs, software labs, and that's just not acceptable. So that's just painful to think. And so that's problem number one. The problem number two is when it's above a design degree day at our campus, we take screenshots of all the chiller plants, pumps, air handlers, and that's our trend data. And they were okay with that. So my problem is you have this data because we can't get that data out. We don't have a way to pull it out from all these different systems without, you know, really just going into each system by system by system. It's just painful. So we made some really big misses on our designs because we really didn't have that data at our fingertips. We were over designing buildings, we missed a few things. So it was a challenge for us to do that. So that's before. We don't do that anymore. So a little bit of after. So I used to get a little teary-eyed on this because I'm doing much better now. So this is, and I'm just scratching the surface today of what we're doing on this. But just to give you an idea, this is one of our executive dashboards. It's usually where I spend a lot of time. It tells me what are the top performing buildings we have. Little arrows go up or down depending on how the building, or each week the arrows go up or down depending on how the building's performing. When I did this, it was at 46 megawatts. The orange is energy, the blue line is weather. So I can see how do we start the campus up. And then we have different, our load segmentation. We think of our energy in 3 different buckets at Microsoft. Base load, plug load, lab load. So base load's core and shell. How long we're in the buildings, common areas. Plug load is people, and this is at the distribution at the floor level. So I'm not going down to each office seeing what everyone's doing, but I am going to the floor level. And then labs is the power for the labs, or the plug load labs. The mechanical is captured somewhere else. But we had the ability to dive in, so I can dive into every building, see what we're doing, and I'm again just showing you the quick version of this. Then this is much more impactful dashboard. This is our operational dashboard. So every building on our campus has pins. These pins equate to the legend here. So does the building have power? Are the generators running? Can I communicate to the building? Are there faults and alarms? And so what this is doing is making the invisible visible. It really is. And so we can dive into a building, and it pulls both static and dynamic, so type of building, type of system. At this time, it was a 2 megawatt. We have 2,000 people. This is one of the largest buildings we have in Redmond. If you see all those numbers by the floor, those are items where the assets aren't working as designed, the terminal units and such. So we can actually dive in here, and it tells me, so all we're doing, quite frankly, all we're doing is adding a tool to the tool belt. That's really what this is. And so we're adding a software layer over all the different systems. So all the different manufacturers, we're pulling the data up. And so I can tell you when did the fault occur, and this is an anomaly where something's not working as designed. What's the issue? What's the priority? So we actually have the ability to prioritize on priority, you know, how critical is the space, and how much does it cost me in wasted energy. So you would think this year at $5,000, you think, well, why would Microsoft care about $5,000? Well, across our campus, so if you give a good technician, engineer, 15, 20 minutes in a terminal unit, they'll tell you everything that's wrong. Give them another 15 minutes, they'll tell you how much it's going to cost you wasted energy. We have 20,000 terminal units. We'll never get there. And so this is a way to really accelerate. And when we first started rolling this out, the technicians, engineers in the building said, you know, we already do 10,000 work orders a month. You're giving me more to do. Thanks, we appreciate it. What they didn't understand, and what we assumed it really had to get proved out, is if you fix the base issues, if you fix the systems aren't running as designed, broken dampers, stuck actuators, all these equipment issues, then the work orders go down because now people aren't calling and saying I'm hot or cold because we're fixing why they're hot or cold. So the 10,000 work orders actually start trending down. Not only that, I save energy, people are happier in their space, and there's a lot more that come out of that as well. But being able to write algorithms that can detect that is great. So again, it gets to the, this is just one floor. So we have priorities of, priority 1 is Microsoft CEO, priority 5 is Daryl, just so we know where the limits here. But we can say, tell me everything in priority 4 that's broken, tell me how much it's costing me. We have fault rules that go up to this. So have the ability to have insight on this. We would never know. These would be invisible. We would wait until I had 58,000 sensors. These are the employees that sit in the building. But we didn't have a way to really distill this to a way that we can act on it. I think that's a key thing is take the data, aggregate it in a way that's actionable. So the other thing is engineering. So again, I kid you not, we were 20% engineers, 80% analysts. We really spun that on our heads. So this one report looks at an air handler over a period of time. So not only do I not just want to see what's not working right this second, I want to see what's not working over a period of time, or how's it work across seasons. So here, this one report is for one air handler, it was building 36, and so it tells us all these great things that it's not doing. So this is airing our laundry, if you will. We have 750 air handlers on our campus. This report takes 6 hours to run normally. Now it takes 2 minutes. So where I could never get to all those air handlers, well now I can. So that's just one of the reports. This is my one of my favorite reports. So we can go out there and say, all right, across our campus, what are the 5 top 100 things that are not working as designed, or set points are not set at the right places, and how much does that cost me? So it starts with $30,000, gets down to, if you aggregate it, it's $700,000. Now this is an annual number. However, if you just fix the top 10 things, you're about $200,000. So it's the ability, and we actually run this once a week and we address all these issues as part of our work stream. It's the ability to really take all this data and not, we used to walk around buildings trying to find what's broken. Why is someone called a hot, cold call? I heard a noise, and we're wandering a building trying to find that. We can go right to what the problem is now. And it's really changing how we do capital planning, how we've done our maintenance, how we do incentivization, gamification. There's a whole lot of cool stuff that go behind this. So a little on the punchline. So how I sold this to my boss is we used to commission or tune each building once every 5 years. So a building comes into our stock, we wait 5 years, and then we retro commission or tune it. And so we snap the building up, we walk away, wait 5 years, and come back and do the same thing, and rinse and wash and repeat. The challenge is, usually what we do is spend 2 weeks in a building in a conference room, hunker down, looking at the sequencing, sensors, all the things you do on commissioning. We'd spend 2 weeks, we'd high five and say, this is great, we just saved, and we typically save about $250K a year and got to about 20% of the campus, but just the big stuff. But the problem is, a controls engineer, best intention, he or she could in 10 minutes erase everything we just did for 2 weeks, and we wouldn't even know it. So that's, again, a challenge. So as soon as somebody sets a set point outside our standards, we catch it. So what we're doing now is, instead of this jawtooth where the building is okay, and I own handover, so my team owns it. So this is, when we get a building that's subpar, I don't want to blame the development team, it's ours. But what's surprising, and I'm a fan of LEED, it's really helped the industry, our LEED buildings were the ones that were wasting the most energy. And at first, I never would have thought that, because handover doesn't go deep enough. Once we've had a building for 5 or 10 years, we were, someone like a car, you kind of know the little nuances and everything, but we didn't really have a way to go deep. In this, so if there's no faults, it's my building. If there's still faults, it's still the developer team's building. And so we replaced the retro commissioning, because as soon as we plug the building in, we know everything that broke. If it starts to break again, we see it immediately. So have the optics, our eyes on the building. Reduce our energy cost by $2 million. We're reducing $8.5 million or 11% in just a couple years. So, and then pay back in less than 18 months. And oh, by the way, I'm the 3rd lowest energy cost state in the U.S. by unit. So Washington has very cheap power. So if I can prove it here, I'm pretty sure I can prove it And we're taking this to Beijing, China. Beijing, China, it's more about persistence. They love to put everything in hand and waste a ton of energy. We'll see it the minute they do. But the best thing here is, you know how you put that dollar bill in your building when you get your first dollar? This is my first rebate check. So we actually are getting, the first one was $400,000. So we actually are getting incentives from the utility company to be doing this, to take this effort in. And so that makes it even more exciting. So I think that's it. So just on the recap, it's 15 million square feet, 125 buildings. We're consuming multiple disparate systems, different protocols. There's two things important you need to know about building data: encapsulation and conversion. Encapsulation is moving the data from point A to point B, but conversion, or protocol conversion, is being able to take, say, the language from the building systems from, say, French to English. Well, some of the building systems speak Martian. So that's one of the important things, is one of the tests of our pilot is the vendors had to prove they could speak Martian, Italian, French, and so on. So that was a really key part, because if we can't get the data out of the building, and that's a fundamental thing here, then we're done. So I think being able to get the data, use it in a very effective way has been, the results been, and we're taking it to our main campuses across the U.S., international, on that. So, yes, sir?
One of the key things that you're doing is computing savings in dollars for the equipment breakdown. How do you measure that? How it's here?
So we know our unit costs in KWH. We have faults. We know there's a formula we use, the short answer. And we're super conservative because we sit in finance. So I want to make sure that we don't catch transients as faults. And so I would say the spigot for us is open 25%. As time goes, we'll open that spigot more. I just have enough to do now. We're going after the big stuff. But it's just a formula we're using across all the assets. We have 225 fault rules that scale 35,000 pieces of equipment, and the cost savings algorithms that go with that.
I think we had the same issue. The issue was it in fault for one day, or was it in fault for 1 year? So we trended back, because we've done the same analytics on a building, and you have to conservatively aggressive make that hedge, because you're looking in the rear view mirror. So you go back as far as you can. We had, with the damper being stuck. What's great about this data is that those of us who are in this space, we're seeing the same thing. It's not rocket science. And it's the same algorithm.
So you compare it to the baseline?
Yeah. So because when we went to senior management and asked for the money to do the same project, they were like, well, how do you know it's been in fault for, all you can do is look in the rearview mirror, come up with a moderate aggressive piece. We took our ROI, cut it in half, and said, okay, and it still yielded 2 years. And with the incentive, and I think we got $190,000 or something from.
That was a kickback to really Randy, is he's going down the same path we are.
Yeah.
A little different flavor of ice cream, but very similar of capabilities and requirements.
It's great to see.
If you have your own determined formula for getting savings, or is it some standard?
There's an industry standard for calculating.
It's NIST standards that we're using. I'll show you what we're doing if you got 2 seconds afterwards.
Thank you, Daryl. A couple questions for Daryl, or comments too. One of the smartest companies in the world, Microsoft, he made a statement. They had billions of data points worth of information, and up until when you didn't do anything with it. How long ago was that?
I'd say 2 years. Well, that's a fair statement. I'd say we ended our pilot in December 2011, started deploying in May of 12, and so that's really where the magic started. And the first problem we had is the first building we connected, we fixed everything. Then we realized this is going to take us 10 years at this rate. So being able to say, okay, well, 80-20 rule, there's a whole lot of process work that goes into this, but it is changing the way we maintain our building.
And I guess on the fault detection, the prioritization, I'm sure that was very important to say, okay, where do we focus our energies and resources at?
Yeah,
right?
we have critical labs that have process. If a lab goes down, I'm going to have a really bad day. So that's where our prioritization may be at times on the space type than the cost. The cost comes really quickly after that. And we could have multiplied it by an emission factor, made it a carbon number, but my team knows what costs are, so that's why we use costs.
And then just the last comment, at 5 cents a kWh getting hydropower, most companies would not even want to consider making the investment or the commitment. So I applaud Microsoft and their efforts. That's great. So next we have Russ with Iconics, and we're anxious to hear about your company and the things you're doing.
Let's see if I can find this here. It was here a second ago.
Oh, it's down on the left, Russ.
Oh,
folders.
actually, yeah, there it is, right there.
Okay. Well, the key to these solutions is to provide the software infrastructure, the hardware infrastructure to make these things happen. Iconics has been in business for well over 25 years. We have 45,000 buildings, systems installed. Johnson Controls, if you're familiar with the Metasys system, that was our product that was running that. We were awarded the Microsoft Sustainability Partner of the Year this past year, and our core competence is to visualize, collect information, large amounts of information, visualize it in easy-to-use dashboards, to provide the analytics against it, to provide the mobilized interface on any glass, on any device, and be able to run this both on-premise and on the cloud. The basic challenges we're seeing out there is that the integration of all these disparate systems, going in and actually ripping out systems is not an option. Things are running, they cost a lot of money, so being able to layer in an interface that collects information using the OPC standards, BACnet standards, and so on, allows the ability to view all this information. Key to saving energy is, as Daryl mentioned, retro commissioning versus continuous commissioning. As you've seen the chart there, retro commissioning, every 5 years go in and just sample few assets in a building. You don't get quite the efficiency as you would get as if you're running it continuously. So the continuous commissioning approach is the approach that we're advocating. With over 45,000 buildings out there, we're doing a very large project right here in Washington, the U.S. Pentagon. They're using our technology to run the entire building. It's about 6.5 million square feet, one of two objects that's visible from satellites. We've also completed over 23 super shopping malls with Talman, and University of Virginia, over 270 buildings, one operations center. They've got 6 or 7 different building control systems, and the largest real estate company in Canada, Cadillac Fairview, which has over 44 million square feet in Canada. To pull all of this together, the key is a software normalization layer, to be able to tie to all these different types of building control systems, normalize the data, historize the data, and then provide the solutions that allows you to connect to that information. Now, this is at the Pentagon. They have a large operations center where they've got multiple screens, and they're watching their water systems. They've got their own water. They've got their own energy systems, because Pentagon has to be a standalone operation. And they call that an integrated operations center, providing situational awareness. This sort of technique's been done for over 10 years, and we're seeing this rolled out at many other locations. Key to this is providing the analytics against the big data. You're collecting all this information. We see 3 key solutions for doing this. One is on providing alarm analytics to be able to bubble up the Christmas tree effect. Sometimes you get many alarms. What was the root cause behind that? Many operations collect thousands and millions of alarms in a particular month. How do you make sense of that? Energy analytics to provide the carbon cost and consumption type data, typical that you see between comparisons of buildings, and of course fault detection, being able to provide the continuous commissioning for all of this. Really what we're trying to do is provide and capture the knowledge, what we call the building whispers. Every organization has the person that goes into it and really helps tune the building, that really understands the building. How do we capture that know-how, create rules around that, and run that on a continuous basis so that you can have the continuous improvements? You have to detect the faults, you have to provide the diagnostics, and you provide the actionable events and fault detection. Once you've done all these analytics, you need to deliver that information to mobile devices, and we use a number of technologies. We run on the Microsoft Surface and Windows Phone. We also deliver HTML5, which runs literally on any kind of device that you like. If you elect, you could run this in the cloud, in Azure Cloud, or run this on-premise. We're doing a lot of NSA data centers. They don't like running on the cloud. They like collecting things from the cloud, but they don't necessarily like running on the cloud. Everything is on-premise there. So cloud-based solutions versus on-premise solutions, it's all a matter of how secure you want your information. And in summary, providing scalable technology that enables savings to visualize, to analyze, and to mobilize. That's a little bit of my presentation. We're over at table 7. If you stop by, drop your card, you have the possibility to win a Windows Surface device because we run on all the any-glass devices. Happy to take some questions.
Thank you, Russ. So let's open up to questions. Yes, sir.
Yeah, Daryl, could you talk a little bit about your massive move, add, change division and how that affects implementing all these things you're doing? We're out there constantly, it's just a huge activity doing all the time.
About the people move?
Yeah, just all the moves you guys do.
So Microsoft does about 35,000 people moves a year. And that's just amazing. It's part of their business. And a challenge with that is, so if you don't like where you sit, just wait, it'll change. But it's really part of their business. The product ships, reorg, and all that. So being able to have, the building was built for a lab building. Now it's an office building. Now it's back to a lab building. So when you build a building originally, it's built for a certain intent. Our intent changes. So a challenge for us is how do you keep maintaining that at the optimum level when the use of the building changes, right? You just can't run it like it was before. So having a little bit deeper analytics to say, this is how we optimize the building. This is how we do metrics on that where it should be running. So that's just a challenge for us.
Yes.
So as far as, one of the things that, Microsoft didn't have a binder of how you made Microsoft building, or how you built it. We didn't have a standards binder until probably the year 2000. So we created facility business systems. Well, by 2000, we had a heck of a lot of buildings. So it was just one of the challenges. But we have business rules. We know when we build a building, what are we going to alarm, monitor, trend on the system, and then naming convention. So I know John will add, so shout out naming convention is that's really key to have that established. Because if you call everything air handler number 1, I'll say you have a problem on air handler number 1. Don't know which building, which floor, but so that naming convention, and that's the asset tree is all built from that.
I wanted to make a comment. The energy analytics side of our industry has become a commodity, and forward-thinking companies like Microsoft, what Iconics has created and is providing to customers, and what Randy is doing and what he'll tell you at Hilton is there's a big delta, big void between the commodity, the data, and the people out there taking it and knowing what to do, or the companies and resources that are available to take that. The existing building stock I mentioned in the last session is huge. It's over 75–80%. The new building stock, well, we looked at fan-powered boxes that have DDC control. That's great. How do we take that same technology and control and deal with those trained pneumatic boxes, that aren't smart, and the upfront cost to, transform them? So anyways, it's just a comment. Yes, ma'am.
Well, a question relating to that, I wanted to ask Randy, to what extent does financing factor into your decision to implement a project? And you actually use PACE financing for a project in California?
Right, for LA.
What was
So PACE financing, that's a real estate tax play. Financing, obviously, is pretty much the kind of, if it doesn't have an ROI, we might think twice about it, but there's so much low-hanging fruit out there, and it's the old less is more. The piece that we've been, our senior leadership, they get it. It's smart business. Now, the byproduct all these projects have is they have a 3-year or less ROI turn. The hardest part of implementing what you're doing and what we're doing the same thing, but we're doing it in a building that's like 1964 that was, and we've got another building we're looking at in 1929. Labor, human capital. This low cost, no cost, the thing, we've implemented many solutions like that. It's not easy. We had one building, I don't know, Marty, help me out, 7 different systems we had to tie together. And just talking to the 7 different systems, we thought it was going to take a week, 2 weeks, a month. 6 months later, we're finally kind of tying it. It's not easy. And it's because of the fact that you also have human capital. We may have 90 maintenance guys working in that one building. We're changing the mindset of our people. We're a mobile nation. This is what tomorrow brings, but we've got to think about who's there. We have some workers that have worked at the Microsoft campus, I'm sure, for 25 years, for our guys that have worked there. So it's the human capital piece. Now, everything we're doing, though, back to your original question, is it definitely yields a high return, and it's high cost, high use. At 4 or 5 cents a kW, that's one heck of a return if it's paying itself back in 2 years. And you can see the basics are right in front of us. When we built these buildings 20, 30 years ago, we had 100% redundancy. They're not broken. We're coming in, we're commissioning, we're cutting some of that energy usage in half. We're implementing the technology that's there. NYSERDA, SDG&E, PG&E, all these grid providers, they want to be there because they need to reduce the load, so they're helping us buy it down. And hence the reason that, in California, that project was $7 million. It was basically ECM motors. I mean, in Hawaii right now, I just got a $1 million project approved to change out motors and fan coils that are only 7 years old. The first thing they asked me was, I thought you told me this was going to have a 20-year life expectancy, but it's a completely slam dunk when you put an ECM motor in. I don't want to plug for the ECM motor guys that are here, but it cut it in half. And then the electric company's like, thank you. And then the Internox of the world and the other demand response guys of the world are coming in and helping us. But so it's obviously the finance is front of mind, but for us it's smart business.
What was your experience with the PACE financing, and would you do it again?
So that's a franchise, and that's a very tough question because if you have capital, there is money comes at an interest rate. Is it 4%? Is it 6%? Is it 8%? So I think when you run that model, we'll have to run that with our business intelligence group. I'll tell you, if you don't have capital and you want to get it done, that is a wonderful model. Now, and it depends. A lot of large owners. We're owned by Blackstone. There is a cost of capital. If we have money, we may want to make that investment directly. I mean, it's a matter of, but the whole PACE financing piece, working with your real estate tax, it's a great idea. So it's a novel idea if you don't have the cash to upgrade your building, and it's a wonderful model for the right owner, for the right asset, and the right piece, and where you are. Every asset's going to have a different value component, short term, long term. So we have to take them all one by one.
Any other questions out there?
Randy triggered something, just a quick comment. On the change management, so we're using a software layer, and I think it's very similar. We don't have to have the folks in the field, the technicians, engineers, he or she is to really learn a new tool, because it's really the air traffic controller can help prioritize workloads. They're still working on the native system, so it's not a big change. It's not like, all right, everybody who's been doing this for 25 years, you're going to have a new tool to work on and enjoy it. It's really not. We're prioritizing their work streams, but they're still working on the native system.
They must be non-union.
Some of our sites, yes, some not.
Any other questions out there? Yes, sir.
So maybe Russ, you can answer this. As you know, we monitor 1 billion square feet from the country, and the school districts and things like that we actively fixing things
Yeah, I mean,
computer to computer
key
before
to
you
this is tying it into your plant maintenance system and be able to automatically generate the work orders. I mean, we work closely with Microsoft to make sure we don't flood the system with a lot of unnecessary work orders. So there is a certain methodology and prioritization that.
But I'll give you a number. 48% of the faults we find, we can fix them in 60 seconds or less. The other 52% we have to roll trucks. But that's, I wouldn't have guessed that when we started this journey out.
And with a lot of the government, the school systems, we're getting up to 70% dispatch avoidance, but they were pretty sloppy before we came.
Great. Are there any other questions? If not, I'd like to thank Iconics for sponsoring this track and our panel for participating today. So thank you very much.
Thank you.
Good stuff.